I'm Ingo Stenner, I'm the IL, Industrial Lubricant Technical Service Manager for Chesterton. I'm delighted to be joined by Hans Decker today.
Hello, Ingo.
Hans is our product line manager for mechanical packing, gasketing and also live loading.
Correct, yes.
Today, Hans, I would like to talk with you about tightening nuts and bolts.
Yes.
For example, tightening nuts and bolts, where do you need to do that?
Yes, very often in industry, bolts are actually being tightened to a certain force.
Mm-hmm.
And the way that is being done is with the use of a torque wrench. So in essence, you have a certain force that you need to apply on a certain bolt, and then you use the actual K nut factor to calculate a certain torque that needs to be applied to the torque wrench.
So if I understand that correctly, you want to actually create a pulling force on the bolts, but you cannot calculate the force directly. You can only calculate it indirectly by actually calculating the torque.
Yes, if you use a torque wrench, that is exactly the case.
Okay, it means for calculating this torque you need a specific factor which incorporates all the coefficient of frictions of the head, the threads, the nut, every other areas as well. So it means it's one factor and it's called the K nut factor.
Yes, that's correct. And that is widely being used because it's a very simple method to convert force to torque.
Okay, so the K nut factor is actually an empirical calculated empirical measured factor. Means it's actually one test and you get one value which is actually being incorporated for the calculation of the equipment.
Correct, that's correct.
Is that still being commonly used in industry?
Yes, the K factor is still commonly used to calculate torques. However, we see a trend in industry nowadays, which has to do with much more stringent emission legislations. So now actually it's especially in Europe, there is a certain legislation and a calculation method for flanges, which is called EN 1591-1, that has to be used in the chemical, petrochemical and oil and gas industries to actually calculate the torques that is going to be used on the torque wrenches.
And that is all over Europe?
That is all over Europe. And I can give you specifically an example of Germany. In Germany you have the emission legislation that's called TA-Luft.
Yep.
And the TA-Luft specifies that you need to tighten your flanges using a torque that is calculated with this particular calculation method.
Okay. And when I look at the formulation of this 1591-1 calculation, it's very, very complex, isn't it?
It's a relatively complex calculation that can really only be done with the use of software. We use that software, quite a lot, and so a certain number of data needs to be entered into the software. For example, dimensional data of the flanges, operating data of the system, but as well, in order to calculate the torque, the friction coefficient for the threads need to be entered, and as well the friction coefficient of the bolt head or the nut needs to be entered in that software. So really, when you're using an anti-seize, those factors really need to be available to do the calculation.
So that means if you have a K nut factor, you cannot really put that into this equation.
No.
Means a K nut factor for this case is of no use.
Correct. If you want to comply with this European legislation, you're going to need these other factors.
So that means you need a coefficient of friction for the bolt head.
Yep.
And you need a coefficient of friction for the threads of the bolt.
Correct.
So Chesterton actually went the way and got everything tested. And I would like to give you the idea that Chesterton 785 anti-seize, as well as other Chesterton anti-seizes, we can actually provide you with this necessary information so that you can be in compliance with European law, with European standards, and therefore calculate everything to the right torque. Hans, thank you very much for shedding some light into this discussion. Thanks a million.
It was a pleasure, Ingo.
Thank you.
Thanks.